What's up, guys? RN Trains here, and today we are going to be talking about microtears and muscle growth and what causes muscle growth. After this video, you will never have to ask or any question about what causes muscle growth. You will know from your own part and end that what causes muscle growth. And it is not microtears. Am I clear? It is not microtears. I have made a very nice presentation for you. You're gonna watch that presentation, and after this presentation, which is made fully by me, by the way, it's not, and you're gonna know what causes muscle growth. Is it micro tears or is it something else? So let's get right into it. All right. So what causes muscle growth? And a lot of you guys have probably heard the term micro tears causing muscle growth, but it is not micro tears. Micro tears are not the ones which are causing muscle growth. Micro tears are a byproduct of training. What causes muscle growth is something called mechanical tension. Specifically here, as you can see, active mechanical tension. Now, there's a general misconception by a lot of people thinking, oh, micro tears are the one which cause muscle growth because once you work out, you kind of just get micro tears and your muscles are then built back bigger. But that's really not the case. That's really not the case. Muscle damage happens 24 hours after workout and 48 hours after workout with the data which we have. It doesn't happen right away. You don't get micro tears right after the workout unless you do something very highly damaging, very highly, like, you gotta do very insane amount of volume for you to get like muscle damage right after the workout, right? But if you're doing regular strength training workouts, you're not getting like muscle damage happening right after the workout, which means one thing and one thing only, that muscle micro tears don't really happen right after the workout, but muscle damage, I don't like calling it micro tears, muscle damage happens about 24 to 48 hours after workout, which means this is not causing muscle growth, right? The hypertrophy stimulus is about 48 hours. Muscle damage peaks after that, right? Muscle damage peaks after 24 hours. Hypertrophy period is somewhere about 24 to 32 hours. The stimulus period for hypertrophy lasts about 24 to 32 hours from the data which we have, and muscle damage markers peak higher after 24 hours, which means what happens is when you stimulate for muscle growth, your body first grows muscle and then repairs the given muscle fibers, right? Which are damaged. Now, what causes muscle growth is this mechanical tension, specifically active mechanical tension. Now, in order for you to understand this particular concept, you have to look at what happens at the very granular, very small in the muscle fiber level, very small into the detail. Like, you see hair, I have hair, I'm balding, I know. You see, I have hair, but can you find like one strand of hair? No, you can't, because it's really a lot of hair, a lot of hair. But if I just, let me just find one hair follicle to pull out. I'm balding for you guys today. Oh yeah, see. So this is one strand of hair. Think about this as, I don't even know if you can see this, but think about this as your one small muscle fiber. Now, okay, let's just put that as a reference value. Now, in your muscles, you have small muscle fibers. Yeah. Now, in this small muscle fiber, you have something called myofibrils. Now, inside of that myofibril, there is sarcomeres. Now, these sarcomeres consist of these two very specific complexes. These two specific complexes are called the costamere complex. Now, the costamere complex consists of two specific complexes, and this is called the dystroglycan and the integral complex. These things are the ones which detect mechanical tension. Now, what you have to understand is what happens is whenever these guys detect mechanical tension, they are the ones which stimulate your muscles to grow. These guys are the ones which stimulate your muscle fibers to grow. Once they receive the stimulus, this is what's causing growth. Now, what is the stimulus either way? What is mechanical tension either way? Mechanical tension is nothing but a pulling force which is experienced by your muscle fibers. Now, when I'm talking about muscle fibers, you have to understand that I'm talking about one strand of muscle, one fiber of muscle, not a whole head of hair, right? When I'm doing this motion, only few muscles are active because this is a very small or very effortless movement, which means less muscles are going to be less muscle fibers are going to be active, which is something which we'll get to in a bit. Yeah. Now, also known as mechanical tension, is what determines muscle growth. Now, very quickly, there are it's not like like mechanical tension is like an on and off switch. It's not really an on and off switch. Like you can't really just turn it off and turn it on, turn it off, turn it on. You can't do that. It has degrees to it, right? You can have high degrees of mechanical tension and you can have low degrees of mechanical tension and you can have medium degrees of mechanical tension. Depending upon the things which I'm gonna depending upon one particular factor. Now that factor is called the force velocity curve. Now this graph is completely wrong, by the way. This graph is completely wrong, and the graph which we have wanted to we should look at is this particular graph. Yeah? Now, now this particular graph is something which determines how much mechanical tension does a single muscle strand, single muscle fiber experiences. Now you can see it's looking very complex, right? It's not that complicated. I'll tell you exactly why. The faster the contraction velocity is, the less amount of force or less amount of mechanical tension which a muscle fiber is able to experience. The slower the contraction velocity is, the more mechanical tension that muscle fiber is able to experience. Let me just give you a small example. This cup, me, I can't do that with a cup. Me contracting my arm pretty fast. That was fast, right? That did not result in very high degrees of mechanical tension. Now, what's this? Using that cup, I'm slowly contracting the cup up. The muscle fibers which are active, which are producing this slow contraction movement upward, are experiencing high degrees of mechanical tension a bit. I know you have one particular question in mind and we're going to get to that. Hold on. Just hold your horses. You have to understand that this is happening at a single muscle fiber level. Okay? Understand single muscle fiber level. And if you remember, I told you something about a sarcomere. Now, there are something called actin and myosin in your sarcomere, right? You probably have seen that one video where Amal like actin kind of joins to a myosin like this, like ek ke upar ek, like one after the other, and then it moves like this, like this, like this to contract, right? Now this kind of contraction which happens when it happens like very slowly, like it attaches, like this is like the actin head, I guess. I mean, this is like the head, and it attaches and it moves slowly upward aage. This attaching and moving slowly upward aage, and is moving like this is moving slowly, slow movement aage. This slow movement is what's causing mechanical tension, specifically high degrees of mechanical tension. Now if this movement, for example, happened like this, slow, very fast, right, that would not have resulted in high degrees of mechanical tension. Now this sliding part is just actin and myosin sliding. You can just search up sliding filament theory if you want to. This will just give you like an example of how this kind of rolling thing works as well. Cool. Now that you understood how mechanical tension works, how much like how what influences the degrees of mechanical tension for a particular muscle fiber, now we are going to come to the topic of the exact question which you have in your head, which is, Raghu, you just told me that you have to do it very slowly, which means all I have to do to maximize muscle growth is perform all my movements very slowly. Not so fast, man. Not so fast. You remember I did a cup thing? Now, do you see me taking any effort when I'm performing this movement? Probably not, right? Now, in your muscles, in your brain, now in your whole body, there are things called motor units. Now, each motor unit consists of a branch of muscle fibers, which means now from here you can have a look at this. Now from here you can have a look at this. You can see this is one motor unit. It consists of a small decent amount of muscle fibers. You can see there's another one motor unit. Oh, this is big. This one's big. It consists of another big chunk of muscle fibers, and this is a bigger one. Bigger one. This consists of even larger chunks of muscle fibers. You can see there's a recruitment order given here, right? What is this recruitment order? There's like something called like an amount of kind of signal which is given. This is, I would just very much simplify this whole thing as a signal, right? This signal, you see, is rising, right? As you can see, the signals are rising. Well, these are essentially the types of motor units you have. This is called a low threshold motor units, which is connected to a very small amount of muscle fiber. This is called a medium threshold motor unit, which is consisting of a decent chunk of muscle fiber, but not a lot. This is called a high threshold motor unit, which is consisting of a lot of muscle fibers. Now, what determines the highest amount of activation? Is it your mindset? Is it the aggression? What is it that's causing this highest amount of recruitment? Well, there is this thing called a central motor command. Basically, the signal which you're seeing, this signal is essentially called the central motor command signal. The more signals you send, the more your body recruits motor units. More motor units recruited, more muscle fibers activated. More muscle fibers activated, more muscle fibers are able to experience that pulling force which causes muscle growth. Now, you're going to be like, how do I get the highest amount of central motor command signal? Or how do I even get the highest amount of neural drive? Now, that is dependent upon your effort levels. The more effort you can put in a given particular movement, the more you kind of have, the more recruitment which you're going to get. Which means one thing, me picking up this glass of mug and curling it slowly upward, this is a very low effort movement, which means only the ones at this lowest end of the motor unit pool are going to be activated and are going to be triggered for muscle growth. Now you're going to be like, oh, so I can always grow these small amount of motor unit, like muscle fibers. Well, not so fast, man. I mean, this is something which you've been using since you were a kid, man. Like these kind of motor units you've been using since you were a kid, bro. So you probably maxed out the growth potentials of these, and if you've been training for about 1.5, 2 years, 3 years, you probably maxed out the growth potential for this as well. The only thing which is left for growth potential is probably the highest threshold motor units. Say like we are talking about a coffee mug, right? Now with a coffee mug, it's not very effortful movement, it's not that heavy. You're gonna recruit the lower end motor unit pools because it's not really that effortful movement. Now if we just give an example of something else, like a bicep curl. Now a bicep curl with a heavier weight, you're gonna have higher effort because it's kind of like a movement which requires more effort. You're gonna have higher amounts of recruitment. Now because of like this, because you have higher amounts of recruitment, you're gonna have more amounts of muscle fibers which are active. Now because you have more amounts of muscle fibers which are active, what's now gonna happen is as you reach closer and closer to failure, you're gonna have the movement velocity which slows down. Right, as the movement velocity slows down, if we came back to the same force velocity curve graph which we have, you're gonna see one thing and one thing only, and that is you're gonna produce the highest amount of mechanical tension for all of the muscle fibers which are active. Which means a bicep curl, a set of 8, for example, a set of 8 of bicep curl, as you reach closer and closer to failure, you're gonna produce the highest amount of mechanical tension. But yeah, so again, I want to summarize this whole thing. Mechanical tension is the main driver for muscle growth. It is dependent upon the force velocity relationship of a single muscle fiber, and that is the main driver for muscle growth, not your microtears. All right, guys, I'm gonna post more videos on this. If you guys have any other questions, or if you didn't understand, just let me know in the comments. I'll try my best to explain things to you as well. All right, see you guys.